Hi everyone, I'm Brock. So today let's keep reviewing on an AI open source project. So this is a Hugging Face website, and the open source project we want to review is called CLAP. Last month, it has. Wait, where's the download? Oh, it doesn't show. Oh. It doesn't show how many downloads it have in this page. Huh? That's interesting. Yeah, it doesn't show the download. But here we can, but from this page we can find that last month it has 50 million downloads. It seems that Hugging Face has some, the UI has some change and it doesn't show download here. Hey, wait. Okay, it's downloaded here. Yeah, as you can see, 15 million downloads. And let's look at the report. This is a table of contents. CLAP, which stands for Contrastive Language-Audio Contrastive Language-Audio Pre-training, is an open source multimodal AI model developed by LAION, large-scale artificial intelligence open network. It extends the concept of CLIP, contrastive language image pre-training, from the image domain to the audio domain. Okay, 3 core functions. Feature 1, zero-shot audio classification. Zero-shot learning refers to the model's ability to classify new categories without task-specific training. Imagine you are a new librarian who has never trained on how to classify antique books. But because you understand the language descriptions, like this book is very old with yellowed pages, you can still categorize it to antique. Antique or antique, let's see how to pronounce.
Antique.
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 Antique. CLAP works like such a language understanding librarian.
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 Librarian. It can classify audio based on text descriptions, like dog barking or car engine sound, even if it has never specifically learned these sounds categories. Interesting. So actually you can see NLP is the foundation of this round of AI tide. Because understanding the text is the foundation of all the other fancy features. Text function 2, text to audio retrieval. Give a text description, find the most matching audio from an audio library, or given an audio clip, find the most matching text description. Suppose you are a film editor who needs to find a thunder during a storm sound effect for a scene. The traditional method involves manually tagging each audio file and then searching by text. But CLAP lets you directly input thunder during a heavy storm. And the system finds the most matching thunder sound effect, even if that effect was never manually tagged. Kind of like, nowadays when we use, the finder, which the searching system, we must use the title of the file to specifically search for it. But maybe in the future, I can search for keywords and it can give me back some files or folders which actually doesn't contain the specific keywords. Function 3, audio embedding extraction. Embedding is a process of compressing high-dimensional data, like audio waveforms, into low-dimensional vector representations. CLAP generates 520-dimension audio embedding vectors. Why 512 dimensions? 512 is equal to 2 to the power of 9, which is efficient for GPU parallel computation. 512 dimensions balance between expressiveness and computational efficiency. Imagine each audio clip has a DNA fingerprint. The embedding extracted by CLAP. It's like this fingerprint. It's a set of 512 numbers that summarize all important features of the audio. Two similar audio clips will have similar fingerprints, just like twins have similar DNA. Core technologies: contrastive learning. A machine learning paradigm where the model learns by comparing similar and dissimilar samples. Contrastive learning is like playing spot the difference. Imagine you are a child learning to recognize fruits. Mom showed you an apple with the description, ripe, round fruit. This is a positive pair. She also showed you a banana with the same description, red, round fruit, which is negative pair. You know that apple and this description should be close, while banana and this description should be far apart. Okay. Dual tower architecture. Dual tower architecture. I feel this open source project is very similar to something we already discussed about before. You see, this is all the other open source projects I already checked before. There's no CLAP, but there are some open source project like CLIP, which is very, very similar. So yeah, I can find some similarity here. CLIP. Yeah, so this is what we already discussed about before. CLIP. Okay. And this is developer, CLIP is developed by OpenAI. And CLAP is developed by LAION. Okay. And another thing I'm thinking about is that for one project, it may have some variants, such as CLIP, right? Yeah, CLIP patch 32 and CLIP patch 14. Since I already go through CLIP patch 32, then I think I should skip CLIP patch 14. This is something I should pay attention. So let me write down in my notes. Okay, let's continue. Because I remember dual-tile architecture is also used in CLIP as well. Dual-tile architecture is a neural network design with two separate encoders that process different modalities independently before comparing their outputs. It's like a pair of translators. The left translator, audio encoder, specializes in translating sound language into numerical language. The right translator specializes in translating writing language into numeric language. After both translators convert their context into the same numerical language, direct comparison becomes possible. Feature fusion mechanism. The technique of combining features from different sources or scalars to create a more comprehensive representation. Why feature fusion is needed? I think feature fusion mechanism is something which CLAP has, but CLIP doesn't have. Audio data varies greatly in length. A dog barking might be 1 second, while a song might be 5 minutes. Feature fusion allows the model to capture both global features, the overall atmosphere of the entire audio, local features, details at specific moments in the audio. Feature fusion is like understanding a city using both bird's eye view and close-up shots. Bird's eye view, global features show you the overall layout of the city. Close-up shots, local features let you see pedestrians and vehicles on the streets. Only by combining both can you truly understand the city. Keyword to caption argumentation. Date argumentation. Techniques to artificially increase the size and diversity of training data. Many audio data sites, like audio site, only have simple labels like dog, bark, without complete natural language descriptions. This limits the efficiency of contrastive learning. CLAP uses T5 model, a large language model. Oh, I never heard of T5. Who is the developer of T5 model? To explain the keywords labels into complete descriptions. Input is the dog, bark, outdoor. Output will be the sound of a dog barking outdoors in a park. But here it mentioned a park, but actually in this image, there may not be in a park, right? It may be under a tree, in a mountain. How you know it's a park? This is like turning a shopping list into full review. But how you ensure that the details you add into the previous shopping list is not hallucination? How? Shopping list like tomato, beef, noodles, and food review will be, this is a steaming bowl of tomato beef noodles with chavy noodles and rich broth. Richer description allows the model to learn more details. Cosine similarity. Cosine equals A dot B divided by the magnitude of A times the magnitude of B. Okay, so cosine similarity is like measuring the directional similarity of two rows. If two rows point in exactly the same direction, similarity is 1. If two arrows point in exactly opposite directions, similarity is -1. If two arrows are perpendicular, similarity is 0. Okay, let's look at the second part. Some terminology and concepts. CLAP, Contrastive Language-Audio Pre-training. It's a model that learns to align audio and text in a shared embedding space. Example, CLAP can classify dog barking audio without even being trained on dog sounds. Interesting. CLIP, Contrastive Language-Image Pre-training. It's an image text counterpart of CLAP developed by OpenAI. CLIP inspired CLAP's architecture for audio domain. Hierarchy. Oh, how to pronounce?
Hierarchical.
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 Hierarchical. CLAP's audio encoder with hierarchical structure. HTSAT reduced model size to 30 million. Parameters while maintaining SOTA performance. Robota, robustly optimized the BERT pre-training approach. It's a transformer-based text encoder used in CLAP. Robota encodes sound of rain into a 512 dimension vector. Then variational autoencoder is a generative model that learns Latin representations. Audio LDM uses VAIN to compress audio into Latin space. What's Latin space?
Latent space.
Latent space.
Latent.
Latent. LDM, latent diffusion model. A diffusion model operating in compressed latent space. Audio LDM use LDM conditioned on CLAP embeddings. MLP, multi-layer perception. A basic feed-forward neural network. CLAP use MLP to project embeddings to shared space. CNN, convolutional neural network. Neural network using convolution operations. Feature fusion in CLAP use the CAN layers. SOTA, state of the art. The best currently known performance. CLAP achieved SOTA on ESC50 zero-shot classification. MAP, mean average precision. A miracle for evaluating retrieval and detection tasks. CLAP achieved 0.471 MAP on audio set. Okay. Transformer, a neural network architecture based on self-attention mechanisms that process the sequential data by attending to all positions simultaneously. A transformer is like an omniscient class teacher. Oh, omniscient, what's that?
Omniscient.
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 Omniscient. Traditional RNN, recurrent neural network, is like a calling roll by seed order. Must start from the first student and go one by one. Transformer can see all students simultaneously and directly focus on the relevant ones. Application in CLAP, audio encoder, HTSAT, text encoder, Robota, embedding, a learned representation of data in a continuous vector space, where semantically similar items are mapped to nearby points. E sub audio equals F sub audio of X belonging to R to the power of 512. Embedding is like assigning GPS coordinates to each person. People with similar personalities are assigned nearby coordinates. So we can tell if two people get along by comparing coordinates distance. Male spectrogram, a visual representation of audio frequency content over time, with frequencies scalared according to the male scale that mimics human audio perception. Human ears are indistinguished low frequency better than high frequencies. The male scale mimics the characteristics. Low frequency range, dense sampling, high frequency range, sparse sampling. Contrastive loss. A loss function that trains a model to minimize distance between positive piles while maximizing distance between negative piles. Info NCL loss. L equals -1, 1 over n, sum from I equals to 1 to n, log of exp of sin of A sub I, T sub I over tau divided by sum from j equals to 1 to n of exp of sin of A sub I, T sub j over tau. If without this pronunciation, there's no way I can pronounce it very well. Simple explanation. Contrastive loss is like a matchmaking, shows scoring system. If a couple is matched, the system wants the compatibility score to be high. If not matched, the system wants your compatibility score below. The model learns to give high scores to correct matches through continuous adjustment. Zero-shot learning. The ability of a model recognize or classify instances of classes if it has never explicitly seen during training. Imagine you've never seen a zebra, but you know what a horse looks like and what straps are. When someone tells you a zebra is a horse or straps, you can immediately recognize a zebra. This is zero-shot learning. It's kind of like how we learn new words, right? We don't know what's, for example, if we understand what's, well, some words is a combination of multiple different words. Like a shirt, right? If you know what's shirt, and then you look at the word t-shirt, then maybe you will understand, okay, t-shirt is a shirt, looks like the letter T. CLAP acquires zero-shot capability by learning a shared representation space for audio and text, giving a new class name, such as helicopter. Text encoder encodes it into a vector. Compare text audio vector with all class vectors. Select the most similar class as a prediction. Okay. System design and architecture. Input layer, preprocessing encode layer. Feature fusion output layer. Okay. HTSAT architecture. HTSAT. Here, hierarchical token semantic audio transformer is a CLAP's core audio encoder based on the swing transformer, shifted window transformer architecture. Okay. Core component analysis. Component 1, patch embedding. A small rectangular region of the input image or spectrogram. Calculation process. The input is 256 mil-spectrogram. Window attention is self-attention computed within local window instead of globally. Okay. Token semantic modules. A CNN nail that maps transform outputs to classic class-specific feature maps. Robota. Robustly optimized the BERT pre-training approach. NSP lacks the sentence prediction. Dynamic masking. BPE tokenization. Byte pair encoding. A subword tokenization algorithm that iteratively merge the most frequent character pairs. BPE is learning abbreviations. If you frequently write artificial intelligence, you might invent an abbreviation AI. BPE does exactly this. Finds character combinations that appear together frequently and merge them into a single word. But why here is a king? Why the token includes a word king? Doesn't make sense. Feature fusion model. Training pipeline. Inference pipeline. Okay, I think that the examples of the algorithm details is pretty solid. At least it gives me some basic ideas of how this mechanism works before I look at any code. Okay, this is how to deploy it on local machine. Timeline. Okay, so this organization actually is just built in 2021, June 2021. So as you can see, in just around 4 years, from the less than 4 years, from when the academic paper is published to today. In AI era, everything is developing or collapsing faster than ever than any age we have seen before. Faster than mobile application age, faster than PC age, let alone the first industry revolution. Co-founders Chen Ke, research scientist, PhD in computer science, is pretty young. He just graduated as a PhD from UCSD last year. LAION is a partner organization of the CLAP project. Okay, so in early 2021, when OpenAI released the DALL-E, Christoph was deeply impressed. He realized that replicating such a model requires large-scale training data, but not publicly available large-scale image text dataset existing at that time. So, as a high school teacher, he started data connection work on Google CLAP. A 15-year-old British high school student, Theo Combis, joined him, and together they extracted millions of image text files from Common Crawl, eventually growing into the LAION organization. You see, just about 4 years, well, less than 5 years, a high school teacher and a high school student together created such a influential organization. That's insane. Okay, the first part. This is some data about the investment. It's important, but I'm not very interested at this moment. So skip it. Competitors, Microsoft CLAP, closed source competitors, Microsoft CLAP, Google USM, Universe Speech Model, OpenAI Whisper, open source competitors, Wave2 CLIP, Audio CLIP, HANS, Trained Audio Neural Network. Okay, it's the last part. Insights. Implication. 1. More clip variants of other modalities such as haptic, olfactory may emerge, forming a unified multimodal representation space. Insight 2. Data quality over quantity. Insight 3. Importance of model efficiency. Insight 4. Network effects of open source models. Business insights. Insight 5. value capture at infrastructure layer. Insight 6, innovation advantage of nonprofits. Trend insights. Insight 7, audio AI is having its GPT moment. Implications for myself. Technical architecture implications. Adopt contrastive learning for multimodal unity. Use CLAP for BGM matching. Data strategy implications. Build a visual novel specific dataset. Product strategy implications. Open source model. Commercialized application layer. Target bilingual Chinese-English market. Positions. Eleven apps. Okay, 11 apps. I already applied for it. Okay, 11 apps. 11 apps. Adobe. Have I applied Adobe recently? No. Technical manager. Let's see whether there's some interesting position for Adobe. Country. No, there's no entry level. Technical account manager. Software engineer. Let's see. Okay, 10 years. It's far beyond my experience. How about a solution engineer? Okay, solution architect. Let's see whether I can limit it to Washington. And sort by most recent. Let's look at this one. Yeah, it seems that this position doesn't mention sponsorship things. So it should be fine. Visa, yeah, it doesn't mention. So maybe I can try, give it a try. Yeah, so solution consultant, Adobe. Okay, let's go back. Yeah, so actually it should have part 6. However, because again, it reached the length of one conversation, so the generation failed from here. Actually, I tried to use research mode to generate this report, and I find actually it's pretty similar to what it's pretty similar to the result when I just use normal cloud without enable research. So I think it's pretty similar. Yeah, this is also pretty, but this one is more precise when I use the research mode. Yeah, that's pretty much it. Thank you. Bye.